So today we will start from free electron model and then come to band theory and band theory of solids that contains conductors, insulators and semiconductors. So we will discuss three categories of the solids: conductors, insulator and a semiconductor. And then we will discuss PN junction. Okay. So yesterday we discussed a little bit about the free electron theory. The first topic is free electron gas theory. Okay. So in free electron gas theory, electrons in solids electrons in solids or conductors are like free gas particles. Gas particles. Particles. Yeah. So they do not feel any force of ions. You know that. Okay, I want to show you a picture. Okay. Okay. So can you see picture? Okay. So in this picture there are electrons. These electrons are, because this is a solid, and inside solid you know that there are positive charges as well as negative charges, electrons. So free electron gas model, these electrons these electrons are free. Okay? Electrons are free. They do not feel any force from these positive charges. These positive charges do not exert any force inside the metal. So their potential is zero. Potential energy inside the conductor is zero. But out of this conductor, if these are boundaries of the conductor, so potential energy out of the conductor, potential energy to the conductor is infinity. Means according to old model, electron cannot come out of any solid, because the potential energy is infinite out of the conductor. Okay, that's why this model was dropped, because it says that the potential outside the conductor is infinite. But you know that according to new models, there is a potential energy inside the uh, solids, that is means due to these positive ions. Means in this model we do not consider positive ions, these positive ions. Okay, these are positive ions, but in new models, that is quantum model, in that model potential energy does vary due to these positive ions, and we also contribute these positive ions. Okay? So therefore now we learn about the quantum model. So in quantum model, this is free electron gas theory, that is classical model. You can write that this is a classical model, that according to which means electrons are free and potential energy inside the conductor is zero and outside the conductor is infinite, and there is no contribution of ions, positive ions of the solid do not contribute to potential energy. Okay, so in quantum model you know that there is a potential energy, and you know that atoms are arranged like this. Inside any metal, so electrons energy, potential energy varies as electron comes near to the positive charge. Okay, so you know that the potential energy formula is minus k q1 q2 over r. So potential energy does contribute in this model. So according to this model, I also draw. Yesterday we drew a diagram. The diagram was like this. Okay? So potential energy inside the material varies. Okay? So with distance, that was quantum model. In quantum model, this is potential energy that varies inside the material. Okay? So that is free gas model. Okay? But according to quantum model, the energies of electrons are Okay, are you listening? So we will discuss now band theory. So we will now discuss band theory. Yes, Amit. Yes.
सर एक्चुअली आपकी आवाज़ मतलब बंद हो गई थी। और सर आप ना वो अनम्यूट करने का वो जो डिसीजन है ना वो आप कर देना, मतलब ताकि हम आपसे बात कर सके। आप सवाल कर रहे हैं ना कि आवाज़ आ रही है या नहीं।
अच्छा अच्छा। नहीं फिर वो जो है बहुत सारे जो है अनम्यूट म्यूट नहीं कर रहे हैं ना, तो फिर मसला हो रहा है, इसलिए मैं ये कर रहा हूँ।
जी जी बिल्कुल सही
ठीक
बात
है।
है ये।
ठीक है।
ओके सर।
ठीक है जी राहुल। जी राहुल। हेलो जी राहुल।
यस सर, ये रिपीट कर दें, आपकी आवाज़ कट हो गई थी।
ठीक है
क्लासिकल मॉडल।
रिपीट करता हूँ। ठीक। ठीक है यहाँ से।
जी, क्लासिकल मॉडल।
तो क्लासिकल मॉडल, according to classical model, that means potential energy inside the solid is zero, and positive ions of the solid do not contribute to the potential energy. Okay? Therefore they do not feel any potential energy inside the solid. But in quantum model, that there are contribution of positive ions. Okay? So there is contribution of positive ions in the potential energy, and the potential energy varies inside the solid. So you know that electron has potential energy that changes as electron comes near to the positive ions, its potential energy decreases, and as it goes away from the positive nucleus, its potential energy decreases, sorry, increases. So that's why, and there are certain energy levels where we cannot have uh, discrete energy, allowed energy states. Okay, so they therefore electrons, as you have already read that whenever we have an electron in atom, individual atom, an atom is positive nucleus and the electrons are surrounded. Okay, so positive nucleus, there are uh, shells around the positive nucleus. Yes.
सर
Yes.
सर ये सब बातें तो आपने कल भी हमें बताई थी, और फिर आपने कल ये कहा था कि ये सब कुछ आपके लिए इम्पोर्टेंट नहीं है।
नहीं अब तो मतलब इतना डिटेल में नहीं जा रहे ना, मतलब ऊपर से ही मैं करवा रहा हूँ। ठीक है, इतना डिटेल में नहीं जा रहे
अच्छा
बस। हाँ
अच्छा सर, और सर एक बात और आप बता दें कि आपने कहा कि इलेक्ट्रॉन जब न्यूक्लियस के करीब जाते हैं तो उनकी पोटेंशियल एनर्जी 0 हो जाती है।
डिक्रीज हो जाती है।
ओके सर, बस यही पूछना था, थैंक यू।
ठीक है। Yes, Akil.
So the thing is now, when the electron comes closer to the positive charge, the potential energy should increase, right?
Yes, when it goes near to the nucleus, its potential energy decreases because it is negative and a positive charge. So when negative and a positive charges comes near to each other, then its potential energy decreases.
But according to the equation, the distance decreases, right? So the
Yeah,
potential energy should decrease.
yeah. Distance decreases. If distance will decrease, it means the potential energy will decrease. If distance increases, potential will increase. Okay.
Distance increase, so potential should decrease, right? So, according to the
Potential,
equation.
if distance decreases, potential increases. Oh, sorry, decreases. Distance
Yeah.
decrease. If we have this nucleus and as electron comes near to the nucleus, so it is potential energy decreases. Okay. And if electron goes away from the nucleus, its potential energy increases because you need to work,
Also,
do work to the electron. Okay.
but the distance between the electron and the positive charge decreases, right? When the electron comes closer to the nucleus.
Yeah, it is decreases. It is potential energy decreases.
So according to this equation, U is inversely proportional to the distance. So potential energy should
But there is
increase when distance
there is
decrease.
a negative sign also. Okay,
So in this
because
case,
one is
it
positive charge,
increases.
other is negative. Okay, so if distance is
Okay,
greater,
thanks.
distance is greater means more negative potential. Okay. Okay. So you may also consider is there is a positive charge and and you can draw a diagram. So if you want to draw a diagram, then you may draw a diagram like this. Okay. So at R is equal to 0, potential is infinity. Okay. Yes, Ariva.
नहीं
Yes.
सर, कुछ भी नहीं है।
अच्छा ठीक. Yes. Rahul. Shoaib. Okay. So according to band theory, now we will discuss band theory.
Sir, I'm sorry to interrupt, but actually I can't compile the idea. Actually, when electrons comes near to the nucleus, so what happens actually about to the potential energy? Sir, can you explain it in just one sentence, please?
Potential energy will decrease
Sir, actually,
because
when you
both charges are positive and negative. What happens when we bring two charges, opposite charges to each other?
sir, you are saying that
Do you
potential
do you require
energy.
any work to do when you bring two opposite charges?
Sir, actually, sir, you said that first you said
No,
that
first,
it increases
yeah,
and then I think that
yeah,
it
yeah.
decreases.
First, when comes near to positive charge and negative charge, it is potential energy decreases because both charges are opposite. You do not require to do any work. But when you move a charge from positive and away, then you do require a work because both are attractive and you do require a work. If you will not do work, how can you move a positive opposite charge from other charge? So whenever there are different charges, opposite charges, when they move away from each other, you do require work and their potential energy increases. But whenever two same charges come close to each other, then you require work if they are same charges. Now here they are different charges, means one is positive, other is negative. When you will bring them closer, their potential energy will decrease. But if you move them away from each other, then it is potential energy will increase. Okay?
Oh, okay, sir. Electron gas theory says that electrons in the metal, inside the metal,
Yeah.
have zero potential energy,
Yeah, zero potential
and
energy.
outside.
Outside the
Uh,
solid is infinite.
okay, sir. I just want to confirm that.
So what band theory says, in band theory, now you already know about the atomic structure, that atom consists of shells. Okay, these are shells K, L, these are names of shells. Okay, and inside shells there are orbitals. Okay, so inside there are orbitals of S, P, D, F. These are orbitals inside the shells, means the location where electrons actually exist. These are places inside the shells. KLM, these are orbitals, and K, L, M, up to so on. These are shells. Okay, and yesterday that we wrote a formula that was 2n square. These are number of electron inside the shell. Okay, not inside the ASPDF. Okay, so this is formula for the shells, like number of electrons inside the shell. Inside shell. Okay, so you can put n1 2 3 4, okay, to find the number of electrons inside any shell. Okay, so for k, n is equal to 1, for l, n is equal to 2. Okay, so when atom is individual, there are, means uh, energy levels. These are energy levels k, l, m, n. These are energy levels, and in energy levels you can draw diagram according to Neil Bohr. Atom has discrete energy levels like this. This is for example E naught, ground energy level. Okay? Energy level means the energy of electron or the uh, orbit where electron exists. Okay, so from the nucleus. So this is for example ground energy level, means in first shell where electron exists, and in second shell its energy level is E2, in E3, okay, and E4. These are energy levels, discrete energy levels of any atom. Okay, as you go away from the nucleus, energy increases. For example, at this level, this is E1, this is E2, like this. These are energy levels. Okay. So these are energy levels inside the atoms. So as you go away from the nucleus, electrons energy increases. Okay. So energy levels, but this is single atom. These are discrete energy levels. An electron cannot exist in between these energy levels. Means these orbits E1, E2, E3, E4. These are allowed energy levels. Means electron can only exist in these energy levels, discrete energy levels. Electron cannot exist in between. These are known as forbidden gaps. Means these are gaps where electron can never exist. Okay. So, for example, if we draw a orbitals, then we can write 1s, 2s, 2p, like this diagram. Okay. So these are the energy. One numbers show shells, and sp shows the orbitals inside the atom. Okay. So when you bring atoms together, when, for example, there is single atom has a discrete energy levels. You have individual single atom. For example, this is single atom and it has energy level, certain energy level. These are all discrete energy levels. Okay. So these are discrete energy levels. So, but these are electrons. Electrons in ground state. In ground state, there are electrons, and in second level, there are also electrons. In uh, last shell, there is valence shell. In valence shell, also there are electrons. Okay. For example, this is a third shell. In third shell, there are electrons. For example, this is electron. So if we bring another atom to this atom, this is, for example, first atom, and this is second atom, So when we bring these both atoms to each other, then what happens, that the electrons energy levels are influenced by the other atom. Means there is a splitting in energy levels. Means when you bring two energy levels, two atoms, so last valence shells are more influenced than the inner shells. So as a result, for example, first there were discrete energy levels like this, for example, at first. But this is, for example, one single atom. And when you bring second atom, for example, now you have two atoms. Then the energy level, for example, this first energy level, that will split, and that will become two energy levels. Okay. So this will become 2, and this will become also 2, and this will become also 2. All these energy levels will get influenced due to bringing two atoms together close to each other, because their electric fields or their energy levels are overlap with each other. If you bring more than two atoms, four atoms for example, then this will become like this, and this energy level will become like this energy level will become like this. Okay, these are four atoms, they make. But if you bring n atoms together, as in solids we have large number of atoms, so these energy levels become continuous and they form bands. Okay, that is known as band theory. So in band theory we say that inside the at solids inside solids energy levels form bands. Okay, means when atom come close to each other they form kind of band, and these bands are just like continuous. In between there is a gap where electron cannot exist. There is gap. Okay, gap between two bands, energy gap, or that is known as band gap. Okay, so highest filled energy level is known as valence band, highest energy band. All these, for example, this is a band, this is for example 1s band, and this is for example 2s band. Okay, first there were separate energy level, one is at first there were single one is band, one is energy level, energy orbital, and 2s energy orbital. Okay, orbital. So these were single at first, but when we brought many atoms together they formed a band. First band 1s band, second 2s band. Okay, and so on. There are large number of bands. These are made by these atoms when we close to each other. Okay, so for example, and there can be also other bands. Okay, so these energy levels are completely filled. Okay, and highest energy band, there are other bands that are also empty. Okay, these are vacant states, means there are no electrons inside these bands. So this band, this highest band that is completely filled, is known as valence band, highest filled band, that is known as valence band. And above valence band there is a band that is nearly empty, that is known as conduction. Okay, conduction band. Yes,
सर एक दफा फिर से जरा बता दीजिएगा वैलेंस बैंड के बारे में.
वैलेंस बैंड के बारे में जी. ओके, सो वैलेंस बैंड का मतलब है कि वो बैंड जो हाईएस्ट, क्योंकि नीचे से आप देखते हैं जो भी 1s बैंड है दैट इज कंप्लीटली फिल्ड. जो लास्ट कंप्लीटली फिल्ड बैंड होगी, लास्ट कंप्लीटली फिल्ड, दैट विल बी नोन एज वैलेंस बैंड. ओके, okay. So now we will yes, yes Ariba, yes
सर कंडक्शन बैंड बता दें.
जी.
कंडक्शन बैंड फिर से बता दें.
कंडक्शन बैंड वो बैंड होती है जो मतलब एम्प्टी होती है, जिसमें वैकेंट स्टेट्स होती हैं ज्यादा, जिसमें इलेक्ट्रॉन के मूव फ्रीली, मतलब वहां पे ज्यादा स्टेट्स जो होती है फ्री होती है, इलेक्ट्रॉन्स फाउंड नहीं होते. तो इसलिए मतलब वो जो बैंड्स होती हैं उसमें इलेक्ट्रॉन्स कैन मूव इजीली, तो उन बैंड्स को हम कहते हैं कंडक्शन बैंड. ठीक है. सो these bands, valence band and conduction band, now we can, this is valence band and the highest band that is empty, nearly empty, is known as conduction band, where electrons can move easily. Now okay, I show you a diagram. Okay, so this is diagram. You can see that these are metals, there are metals, semiconductors and insulators. Okay, so in, now we can describe material, uh, all solids on the basis of three subcategories. One is metals. In metals you can see that valence band, that is red here, and blue, that is conduction band. So in metals these both bands overlap with each other, means they are very close to each other, means they have an overlap, they have a common region to each other. Means like if you apply a little bit electric field, the electron will start moving. Okay, and in semiconductor there are there is a energy gap between them. So in here you can see this is energy gap, Eg. Okay, energy gap, and this is known as also band gap. And you can see that in semiconductors there is a huge energy gap, means, and a conduction band is empty. Okay, there are no electrons in conduction band, and in semiconductor the valence band is completely filled, and a conduction band can have few electrons when when you increase the temperature. If you increase the temperature, then there will be few electrons that will jump from valence band to, for example, in valence band there are electrons. Okay, so when you increase temperature, so few electrons will jump to the conduction band because energy gap is very small. So energy gap between valence band and the conduction band in semiconductor is about 1.1 electron volt. Okay, so at room temperature there might be few electrons jumping to the conduction band, and as they jump into the conduction band there are holes. As electron, for example, uh, as electron jumped here, so there will be holes remaining inside the valence band. These holes are the places where electrons are absent, and these holes also play role of charges, and their charge is plus E. Okay, means they are just positive charges. Means now electron can also move inside the valence band too. As electron jumped from valence band to the conduction band, so now their conductivity increased. So in semiconductor, as you increase the temperature, you increase the conductivity of the material. Okay, but in semiconductors are mainly germanium, silicon, gallium arsenide. So there are many other uh, semiconductors, but here only we will study silicon. Okay, so the insulator, you can take its example as diamond. Diamond is example of uh, insulator. Okay, so insulator, so actually structure of silicon and the diamond is same, but the band gap of both are different. Insulator band gap is about 5 electron volt. Okay, and a greater than 5 electron volt, and in semiconductor their energy band gap is small, 1.1 electron volt. So electron can easily jump inside the semiconductor from valence band to conduction band, where electron can easily move. But in insulator, electron cannot move without a huge energy, substantial energy. Means you require a large amount of energy to provide insulator to conduct. Okay, and the conduction band is completely empty inside the insulator. Okay, so these are, that is known as band theory. So according to band theory, you can define uh, the conductivity of material. So conductivity of semiconductors. So we discussed now semiconductors conductivity. So semiconductors, energy gap is small as compared to insulator. Insulator. And now you can see that in insulator, in carbon, there is 5.4 electron volt energy gap. In silicon, it is 1.1 electron volt. And there are other also semiconductors. Okay, germanium. Okay, and a tin. These are semiconductors, and their energy gap is 0.72 and a 0.08. And in metal, there is, yes, Sanali.
Sir, can you show us the diagram of diamond and silicon so that
There is no
we
any
can
diagram.
visualize?
You can see on internet. Okay, their diagram is same. Okay, their structure is same. So you may refer to internet. Okay,
So how can we visualize मतलब के energy level bands between them?
energy band gap, that is different thing. And you want to see the structure.
Yeah,
Structure,
so
structure is means you want to visualize inside structure. That is different. That is we find through X-ray diffraction structure of material. Okay,
so
so through X-ray diffraction we can find inside the structure of any solid. Okay, these are completely different topics. Okay, so we are
okay,
just studying here band gaps. And the band gaps means you require more energy as you see physically, means real life example, that you cannot pass current through diamond. Can you pass? Why
I
you
don't
can't?
know.
Why you can't pass? Like, you cannot pass any current through a diamond. Diamond is an insulator. Why it is insulator? Because its band gap, energy band gap is huge. You cannot supply enough energy to flow current through diamond, but you can flow current through semiconductor, because you know that transistor is a semiconductor, and diode is semiconductor. All these components are, why these are semiconductor? Because you can make current flow through these components. Okay,
Okay, sir, you told us about some energy values of energy bands,
yes,
1.2 or something. Sir,
yes, yes.
that we make remember.
Okay, yes, Javier.
सर
Yes,
हम बैंड गैप को फॉरबिडन बैंड कह सकते हैं
जी जी, फॉरबिडन गैप्स, इसका मतलब है कि वहां से
ओके
करंट
सर
फ्लो नहीं होगा। ठीक, वहां
ठीक
पे
है।
एनर्जी स्टेट्स नहीं है वहां पे, ठीक है। So and in metals you can see here that in inside metals the band gap is 0, means there is no any forbidden gap, and they can easily conduct current. Okay. Yes. Yes, Javiria.
नहीं सर, मैंने नहीं करा।
अच्छा ठीक। ये सरीवा। ये सरीवा
सर
जी।
सर हमारी आज 12 बजे भी क्लास है, तो अगर आप जल्दी इसको कंप्लीट कर दें तो।
कितने टाइम में ये क्लास आपकी?
12 बजे की।
12 बजे?
यस सर।
मुझे सीआर ने तो नहीं बताया था, किसी ने बताया तो नहीं था।
सर हम सब ने कल रात जो है ग्रुप में मैसेजेस किए थे, लेकिन किसी ने रिस्पॉन्ड नहीं किया था।
अच्छा,
या तो फिर आप
क्योंकि
बात
ज्यादा
कर दें,
ज्यादा मैसेज आ जाते हैं ना ग्रुप में, तो फिर देखना मुश्किल हो जाता है।
या फिर हम उन वाले सर से कहें कि आप थोड़ा वेट कर लें।
चलो ठीक है, ऐसा करते हैं, कल एक एक्स्ट्रा क्लास रखते हैं, फिर इसकी आज जो है खत्म करते हैं। ठीक है,
ओके सर, थैंक यू
ठीक,
सर।
कल एक एक्स्ट्रा क्लास रखेंगे।
ओके सर।
ठीक है,
लेकिन सर फिर कल जो है ना सेक्शन ए वाले जो हैं उनकी क्लास होगी। आज जैसे हम सेक्शन बी
अच्छा जी। यस यस यस।
सर तो मतलब ऐसे हो जाएगा कि आज 1 घंटा पढ़ा है तो कल भी 1 घंटा पढ़ लेंगे 11 से 12 तक।
ठीक है, कल 1 घंटा कल करेंगे।
सर 11 से 12 कर लेंगे कल।
11 से 12 ही करते हैं, ठीक है।